Plastics have become a hugely important material in modern society. From the pipes that flow under our cities, to our clothes and our coffee cups, the applications of this modern material are innumerable. Indeed, the throughput of plastics in our economy is vast, with high rates of consumption and subsequent waste outputs. As a material, however, plastics pose a number of threats to our environment. For example, build-up of unbiodegradable plastic debris can contaminate soil and groundwater and pose a serious threat to wildlife. To achieve a more sustainable use of plastics requires improvements in resource efficiency. In other words, we must learn to produce more from less, more goods and services from less of the world's resources, whilst generating less pollution and waste. With regards to plastics, this requires a dematerialization of the economy, whereby raw material inputs and subsequent waste outputs are decreased over time. One major effort to improve the resource efficiency of plastics has been through recycling, whereby wastes are recovered and reprocessed into usable products. Some materials can be recycled in a closed loop, a continual cycle of reprocessing materials into products with equivalent properties. For the majority of plastics, however, this is not the case. Most plastics are in fact downcycled, reprocessed into products requiring lower quality material. For example, the plastic container you recycle at home won't be turned into more plastic containers. More likely, it will be turned into carpet fibres, which will eventually end up in landfill. The fundamental problem with this system is that it doesn't stem the demand for more virgin petroleum products. Furthermore, there is evidence to suggest that the ability to recycle plastic is causing a rebound effect, leading, paradoxically, to increases in plastic consumption. Thus, on the whole, plastic recycling is a highly limited process with regards to plastic dematerialization. In order to achieve more successful plastic dematerialization, greater effort must be placed on reducing plastic demand. Ultimately, however, this must be coupled with a fundamental transformation in the design of plastics, so they become environmentally passive, cradle-to-cradle materials, which can enter continual, cyclical resource systems.